All right, here we go. Welcome back, babies. We're doing the homework for tonight. Got some tough questions on here, I think. We'll see how they go. Shout out to my friends Carly and Claire, who said they actually listened to the audio while they watched the videos. I don't know. We'll see how that goes. All right, crew. First question. It says a rectangle has a length of 6 and a width of 3. It is rotated about its length to create a 3D solid. What is the surface area of the solid? So I'm going to go down here. I'm going to draw myself a rectangle. And it says it has a length of 6 and a width of 3. And we're going to rotate it around or about its length. Now remember, these are 3D rotations. This is not a 2D rotation. I'm not talking about doing this. That is not what we're doing. We're spinning in 3D space around that blue line. That is the axis of rotation. So what you do is you draw the reflection on the other side of the axis. And I'll highlight it blue again. And you connect the opposite vertices with a circular motion. So you go circle, 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 circle. It's spinning around that axis. Circle, 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 circle. And what shape would this form? A nice cylinder. I don't know if you can picture that. Maybe it helps if we stand it up like this, but this is a cylinder, my friends, a cylinder. What are the important pieces of this cylinder? Well, from the middle to the edge is 3. The radius is going to be 3, and the distance between the bases, the height, is going to be 6. So we need to find the surface area. So the surface area is 2 pi RH plus 2 pi R squared. That's just one of our formulas. We talked about that a few classes ago. That'll be 2 pi times 3 times 6, 2 pi RH plus 2 pi times 3 squared. And so we would have, let's try doing this without a calculator as much as possible. 18 times 2, 36 pi. 9 times 2 is 18. Those are like terms. 36 plus 18 would be 54 pi. Nailed it. So that's the first one here. I'm going to move this out of the way. That's for the, I don't know where to put it. I'm going to slide it right on up there. All right. The second one says a right triangle has a base of 5 and a height of 10. So let's draw a right triangle with a base of 5 and a height of 10. It is rotated about its long leg. So I'm going to scoot this over. So the long leg is the axis of rotation. And so what did we do? What's the plan? We take the shape and we spin it, or we reflect. I don't think there's a way to do what I want to do. That's okay. That's okay. So what we'll do is I will just draw the reflection myself. So here we're spinning it around this. It won't be perfect, but it'll be pretty darn close. So we want to be the same distance out. Aw, it didn't. Aw, okay. I'm just going to eyeball it, and you guys know my eyeballs are terrible. So it would go this direction. I don't know, something like that. Okay, it's getting messy. Okay, here we go. So it'd look like that. That's pretty good. And then you spin, you connect the opposite vertices in a circular motion. It's spinning around that axis of rotation. And so what would this make? It would make a cone. And it wants the surface area of the cone. A cone, the surface area is pi RL plus pi R squared. The radius, if we look at this picture, the radius would be the 5, right? From the center to the edge would be the radius. Now the slant height is formed, it's from the apex to the circle, but there's this right triangle that we've worked on where it's the radius, the height, and the slant height. So for this right triangle, we have the numbers 5 and 10, and we want the slant height. So that would be the square root of 10 squared plus 5 squared. Well, I would divide by 5 That'd be 2 squared plus 1 squared. That'd be the square root of 5. Multiply the 5 back in, it's going to be 5 root 5. So do you remember those skills at all? You can use a calculator for now, but we're trying really hard not to use a calculator. And the best way to do Pythagorean theorem is to reduce the numbers, do Pythagorean theorem, and then unreduce the numbers. That's the best way. So the slant height is going to be 5 root 5. So the surface area is going to be pi times the radius times the slant height plus pi times the radius squared. Trying hard not to use a calculator. This would be 25 root 5. Don't forget there's a pi. And this would be 25. Don't forget there's a pi. Now it does tell us to round it. Let me type this in, make sure I get the right answer. 25 root 5. Don't forget there's a pi plus 25 pi. And I get 254.160, which is the answer. Crushed it. All right, moving on. It says find the area of the region bounded, and they gave us 3 graphs. So first off, try to remember all about the Hooy-Vux. Horizontal lines, 0 slope, y equals. Vertical lines, undefined slope, x equals. So when they say y equals 0, that's the Hooy, horizontal. Let's go a little thicker. The horizontal line for y equals 0. You go to where y equals 0 and you draw a horizontal line. We have x equals 0. So we go to where x equals 0, vux, vertical, and we draw a vertical line. So we have those two. And then we have negative 3 halves x plus 9. So we go to the y-intercept of 9, and that's down 3, right 2. It's a slope of negative 3 over 2, negative 3 over 2, negative 3 over 2. I caught it. Negative 3 over 2, and finally, negative 3 over 2. And so this is what I just asked you to graph. And the bounded region, I'll do, let's do this. Oh, we already used red. We'll use pink. The bounded region is the region in between all 3 lines that we just drew. So it's a right triangle where the base is 6 and the height is 9. So that area would be 1/2 times 6 times 9. And that would be 27. Got it. Perfect. Number 3. Let's do some more graphing. I'm going to graph y equals 0. Hooy, horizontal. Hooy, horizontal. X equals 3. So go to 3 and Hooy-Vux, vertical. X is vertical. And x equals 9. Vux is vertical. Vertical. All right. And then we're going to graph the equation, negative 2/3 x plus 8. So we go to 8, down 2 over 3, down 2 over 3, down 2 over 3. And I am going to stop right there. I actually only care about the bounded region. So let me actually I only care about this part. So you could draw the whole line if you want, but we're trying to get the area of the bounded region. Well, that bounded region makes a trapezoid. The bases have to be parallel, so the 2 green lines would be the bases, and those are 6 and 2. And then the height would have to be this third side, the distance between the bases, the perpendicular line, 3 to 9 would be 6. So the area of a trapezoid is 1/2 base 1 plus base 2 times the height. So that's going to be 1/2 base 1 plus base 2 times the height. We plug those numbers in. So that's going to be 8 times 3, which is 24. Nailed it. 8 is 6 plus 2. 3 is 1/2 times 6. Okay. Good work. Find the area of the regions bounded by these 3 graphs. And I can already tell this is a fun one. So we'll do y equals 1/2 x plus 12. So we go to plus 12, and we go 1/2, 1/5, 1/5, 1/5. So that's up 1, right 5, 1, 2, 3, 4, 5. Up 1, right 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. And I'll do one more. Up 1, 1, 2, 3, 4, 5. I don't know how many I'm going to need, but I'll just make the whole thing. It's going to look something like that. Okay, and then 3/2, oh dear, it should say y equals 3/5 x plus 4. So 4, up 3, right 5. Up 1, 2, 3, right 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. And if you know me, you know I'm blind in my right eye. Like I have a hard time like looking at 15 and knowing where it is up here. So I just count. That's just me. So I'm sorry if that's annoying. But 1, 2, 3, 1, 2, 3, 4, 5. And then I counted wrong. 1, 2, 3, 1, 2, 3, 4. There we go. And then 1, 2, 3, 1, 2, 3, 4, 5. There we go. It's shaping up. So we can stop when we hit the black line. And then let's do the last one, y equals 7/5 x. That's going to start at 0. It's going to go up 7, right 5. Gotcha. Up 7, right 1, 2, 3, 4, 5. It's 5, right there. There we go. Perfect. So I'm going to erase the excess. So now we know exactly which parts we need. I'm going to erase the excess. We want this part of black and just this part of green. This is the triangle that we want. Okay. There's multiple correct ways to do this. One of those ways is to pick a good line to draw that would cut it into 2 smaller triangles. Now, when I say a good line, we want it to be vertical or horizontal, and we want it to hit an intersection perfectly. In other words, we want it to hit whole numbers. For example, if I did it from this point, not helpful. Neither one of those vertical or horizontal lines would ever hit the triangle. Same thing over here. Neither one of those are good. From the middle, we have 2 options. We could go down or we could go right. Going to the right is a bad choice. That's not an intersection that's easy to get. But if I go down, that is an intersection that we can see clearly. So this is how I would do it. And I'm treating it like just any old triangle, guys. If I gave you a triangle that looked like this, and I asked you to get the area, this is really important. The green line, let's say the green line's like 6, I'm just making that up. The height is over here. Bases and heights have to make a right angle. That's the only rule, right? If you kept going, that's where the right angle happens. They do not have to touch. A base and a height don't have to touch. They just have to form a right angle. And that's a big issue for a lot of people. So this one would be 1/2 times 6 times 3. That would be this scenario. Base and height make a right. So if it's an obtuse triangle, you do not always have bases and heights that touch. And that's okay. And that's okay. All right. So why am I telling you this? So we're going to focus on this red triangle. I'm going to call it the red side. The base is going to be this blue line. That base is 1, 2, 3, 4. That base is 4. This is the farthest point. This is the height out here. 1, 2, 3, 4, 5. So that side is 1/2 times 4 times 5, which is 2 times 5 is 10. That's just the blue side. Then we're going to do the other side. I'm going to call it the pink side. So for the pink side, we're going to use the same 4, but now we're going to this vertex. And our height is way out here. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the pink side is 1/2 times 4 times 10, which is 20. And so the combined area of the pink side and the blue side must be 30. Nailed it. That's a tough question. Yeah, that's a tough question. All right, moving on. Find the area of the bounded region. Oh, we only have a few more. We're almost there, guys. Oh, man, I don't like it when we're this close. I want more questions. I'm going to start with x equals 0. Hoi vux, vertical at x equals 0. It's going to be this line here. Vertical, x equals 0. Vertical, x equals 0. Y equals 6. Horizontal at y equals 6. Hoi, horizontal. Y equals is horizontal. And then y equals 3x. That's a 0. That's up 3 over 1. Up 3 over 1. And I don't need to draw the whole thing to know that this is my bounded region. So it says the region bounded by blank is rotated around the y-axis. So I drew way too much. I'm going to clean this up a little bit. So the y equals 6, I only care about this part. And the x equals 0, I only care about this part. I only care about the bounded region, this triangle. And I'm rotating it around the y-axis. Fellas, friends, people. Even after we get really good at this, the number one mistake I actually see on the test is people rotate these around the wrong axis. This is our axis of rotation. It is this blue axis. So what are the rules? We draw the reflection on the other side. So we're going to go to -2 on the other side up to 6. So we draw the reflection on the other side. And then we connect opposite vertices with a spinning motion. And what we have here is a cone. The radius of the cone would be this small space here. That would be 2. The height of the cone would be from 0 to 6. So we have a right triangle we need to solve with a 2 and a 6. So let's do that. That'd be the square root of 6 squared plus 2 squared. I would divide by 2. That'd do 3 squared plus 1 squared, which is 10. But since I divided by 2, I have to multiply the 2 back in. So this is 2 root 10. So our formula for surface area here is going to be pi RL plus pi R squared. So we plug in our numbers. The radius is 2. So that's pi times 2. The slant height is 2 root 10 plus, what am I doing? Let's go down here. It's pi RL plus pi R squared. R equals 2. Slant height equals 2 root 10. So it's pi times 2 root 10 plus pi times 2 squared. That's going to be 4 root 10. Don't forget a pi plus 4 pi. If it said leave exact, we're done. These are unlike terms. Make sure I got the right numbers. I'm feeling good about that. I typed that in. Hopefully we got the right answer. 4 root 10 times pi, use the pi key, plus 4 pi, use the pi key, 52.305, nailed it. All right, perfect. Last one. Oh no, we're already here. All right. We are going to do y equals 3x. So we're going to start at 0. We're going to go up 3 over 1, up 3 over 1, up 3 over 1. And I'm going to go down 3 over 1 as well. I don't know how much of this we need. It's going to look something like this. Okay, so there's y equals 3x. I usually do my x equals, I did the wrong pattern. X equals 0, That is Vux, vertical is Vux. Y equals 6. That's the whole part. All right, so now we got our shape. So I'm going to outline our shape in red. Change it up just a little bit. This is the shape that we're rotating. And then I can quickly erase the extra. All right, so that's the triangle we care about. And this is going around the x-axis. Yikes. So it's at 2, 6. So I'm going to go to 2, -6. I'm going to draw the reflection. And then I'm going to start spinning. We're spinning. We connect opposite vertices. Connect opposite vertices. Woo, that's tough to tell. That's a hard one to see. This is going to be a cone-shaped cutout. There's one of these in the example video. You can go watch. It's drawn a little bit better. This one's so thin that it's hard to see. But we have a cone-shaped cutout of a cylinder. I'm going to do this kind of quickly. You can go watch the other video if you want to see another one of these. But what do we have? I would do the lateral of the cylinder plus 1 base. So the cylinder part, we have the lateral, we have the outside lateral plus 1 base, the bottom circle, the left circle in this case. And then what part of the cone is exposed? The cone doesn't have a base, that's a hole. We have the lateral of the cone. So this is going to be our plan. So what are those? That's 2 pi RH plus pi r squared. That's the lateral of the cylinder plus 1 base. And then the cone is just the lateral, pi RL. So what are these numbers? Well, the radius would be 6. The height would be just 2. And then those are actually the same numbers we just did, right? 6 and 2. So this would be like the slant height of the cone. Oh, that's hard to see. Hopefully you're drawing better than me. But we just did the number 6 and 2. It's the same numbers, so we know it's going to be 2 root 10 for the slant height. All right, and from there we're just plugging in. So it's going to be 2 pi times r times h plus pi times r squared plus pi times r times 2 root 10. This would be 24 pi plus 36 pi plus 12 root 10 pi. That'd be 50, that'd be 60 pi plus 12 root 10 pi. I'm going to type that in. 60 pi plus 12 root 10 times pi. And that is 307.711. That's a doozy. Good luck, my friends. I'll see you next time.